G'day everybody. After pulling the transmission apart whilst I was away from home, when I got back I decided to rebuild the valve body on my transmission. Unfortunately, due to a faulty part that was supplied by ZF, I had a bunch of problems, which I'll talk to you about in a moment. In the process of that, it actually took me about a month or so to chase down what the actual issue was, and I probably pulled the valve body out of the car maybe half a dozen times and looked through hydraulic diagrams and just studied as much as I possibly could to try and find out where it was. So I eventually tracked down the problem, and what I'm going to do now is just talk to you about what I learned about the valve body. I guess I learned a lot more than what I knew previously, and I'm just passing this on so hopefully some people get something out of it. Firstly, when I was pulling the valve body out of the transmission whilst it's out of the car, obviously everything is upside down, but when it's actually in the car, this is the way it would actually be sitting. You would have the two pipes that go into the pump, which is part of the C-clutch part at the front of the transmission. You have the bit from the filter, and this is the bit that actually comes down from the pump. This is the pressure regulating spring, and then it would go in under the channel plate and through the remainder of the valve body. I've obviously pulled everything apart. You have the upper front valve body there and the upper rear in this position here. What I found was probably the easiest way to do things. I made myself up a little stand, which is this thing. It's just got 4 6mm threaded bolts through a piece of timber, and actually bolt this to a transmission jack. I'm fortunate enough to have a lift in my shed, so I just use the transmission jack and I actually sit this underneath initially the pan when I lower it, and then so I can lower things down nice and easily. But for the valve body, putting that in and out, that made it a very, very simple task. Most people won't have a lift. However, you can buy attachments for a normal trolley jack that you would be able to put something like this on that quite happily, and that would actually make the job much easier, as well as reduce the risk, in my opinion, to damage to the valve body, especially putting it back in again where everything's nice and clean and you want to align everything perfectly. So when I was removing the valve body, initially you just drain the pan, then I'm going to put the plug back in again. I'm then going to put my little transmission or the pan holder underneath it, drop all the bolts and then lower it down. And then, with that sitting probably about 2 feet underneath it, I'm going to lower the actual, I'm going to loosen the bolts on the valve body itself. Now, the differences between, because there are actually a number of differences between this valve body that I pulled apart, which was an earlier version, and a later model, which mine has, and I think there have even been more updates since, is that on this one, all of the bolts were T27. There were different sized heads, but they're all T27, which made it a bit confusing to work out which bolts you actually had to drop from the underside to remove the valve body. There were a number that I thought I needed to remove initially, when in fact you don't. Now, or certainly on my transmission, which is a later model, all of the bolts are now T40. They're large head. They're still a 6mm bolt, but they've actually got a T40 head, so it's pretty obvious from underneath which ones you need to loosen and which ones you don't. There are only 3 at the rear. There's 1, 2, 3 here. Now, other of these holes actually go up into the transmission for pressure to activate the clutches. But there are a bunch of other holes here that look like you would pull bolts from theirs, but you don't have to actually get the valve body out initially. There are another 11 up the front, and so it's 14 in total. So what I did was I lowered them down. You can bring those down about 8mm or so. And what that'll allow you to do is actually separate the valve body from the actual remainder of the transmission, and a lot of the oil will actually just drain further down. So I actually sat the transmission, the pan, probably a couple of feet underneath it, dropped the actual valve body, still sitting on the bolts about 8mm or so. And also the nice thing is, because these are actually just sort of slightly jammed in there, they will just fall nicely under the weight of the transmission and just slide out all by themselves. And what that'll allow to happen is a lot more oil to come out. Initially it will allow a little bit to come out, but then you'll hear this glugging sound and it'll drain about half of the torque converter as well. So initially you might get from an initial drain maybe 4 or 5 litres of fluid. You'll probably get another probably 2 or 3 litres of fluid out of it after that. So in total you might end up with 7.5 litres or so. that actually took a fair while for it to drain out, so go and have a brew or a beer or something like that whilst it does it. What I found also made it much quicker was having the transmission warm when you do it. Don't have it at operating temperature, but about 50 or 60 degrees Celsius is kind of nice, because what's going to happen is everything will run out really, really quickly. You'll hear this glug, glug, glug as the torque converter empties, and then it'll be pretty obvious when everything stops. When I did it once when it's cold, it probably took maybe well over an hour for it to drain, whereas if you have it nice and warm, it'll take about 10 minutes or so. When you actually then remove the pan, remove all the oil away, then I'm going to use my little transmission holder to actually sit underneath and sort of put these in particular spots. They would be pushed up against the bottom of the valve body, so everything's supported, and then I can remove those remaining, all those 14 bolts, okay, and then lower it down to pull the thing clear. Obviously you would need to remove or disconnect the output speed sensor, push the plug out, the main plug that goes to the harness, and disconnect the little plug for the inlet speed sensor as well. And then what will happen is this will lower down nicely. This one here, which is from that goes to the filter, will probably just pull out and just be sitting sort of at a funny angle, loosely. This one should stay solidly connected inside the transmission pump, and so it should be completely disconnected as you pull it away. Obviously, you know, everything's pulled apart at the moment, but then you would make a stand, sit it nicely, remove everything. I found if you didn't want to completely clean out everything, cling wrap is a really good tool. So as soon as you pull something out, wrap it in cling wrap really thoroughly, put it away safely, and then you won't have to clean everything out. It'll keep any dust or anything like that out of it, which you clearly want to be able to do. When you get to the point where you're looking at this, which is, and obviously we would have the gasket in between these two, I'm just keeping that out of there just for simplicity's sake. So when this inside is going to be full of oil, you've got all of these orifices which are going to be stuck in different positions in here. So I'll just put one in here. There's a problem I had initially was that depending on the oil flow as you shut down the car, those orifices will be either pushed up towards the spacer plate, or they're going to be pushed down. If they're pushed up, they're actually going to stick to it. If they're pushed down, they'll just be sitting nicely. And the problem is that as you lift this up, a lot of them are going to be stuck to the underside of it, and it's going to be difficult to work out exactly where they need to go. What I suggest you do is get a poker, something that's really clean, maybe a little drill bit or something like that, and I'm just going to go around each of those holes that have an orifice, and I'm going to poke those down to make sure they're seated down nicely. And then what that'll mean is that when you pull this up, they'll all be sitting in the correct spot. You'll be able to take a photo of it, because obviously it's fairly important to put those in the correct position when you put the transmission back together again. Something that was different about this transmission compared to the one that was in my car, there's obviously been updates for especially this part, the channel plate, is that firstly the orifices, you can see here, and as I put online on E46 Fanatics, a lot of them were same colour for different sizes. Now they've changed them to different colours. There are still different, like brown of different size, but one's really small and one's really large, so it's blindingly obvious. But I know, for example, these white ones here, which are thin, are now purple in mine, and I'm expecting that probably a lot of people are seeing that. Also, with the one-way valves, these things here, for the two that had the short springs on them, they were actually yellow now, and the things actually stick together rather than falling apart really easily. So it makes it a little bit easier to work out where things actually needed to go. On E46 Fanatics, I put up a sheet which has a guide of the old and new of the orifice colours, so hopefully that'll help people out. Other things that were a little bit different, there were places, for example, in here, and I think there was another one in here, where they don't have an orifice anymore. The orifice itself is now in the spacer plate, and it's a bit difficult to see on the camera, but all over this there are tiny little holes that are quite specific sizes that are all over the valve body, and they obviously allow flow both in and out of that hole at a specific rate. What the orifices do is they allow that orifice to work in one way only. So for example, if this orifice was in here, when oil's going down into it, it blows it away. It can actually go out very freely, whereas when it's come up, it gets pushed against the valve, the spacer plate, and only allows it at that metered rate. So that's the reason for the orifices, so they work in one direction only. All over here, there are little orifices that work in two ways only, and they've obviously worked out that in a couple of these places, they preferred to actually have it as a two-way orifice rather than just a one-way, because on this spacer plate, where that orifice was on this one, there's a big hole, whereas now on mine, with the updated one, it's actually a tiny hole, which is that specific size, so it works both ways. If you look at the catalogue of the parts for the valve body online, which you can download very, very easily, for those positions, now they just now point to it and say it's open, so they don't actually have a specific part that goes there, which is a little bit confusing. If you have an earlier valve body, it's obviously critical to work out where those orifices actually need to go, because they won't be listed on the current parts catalogue. Other things that are also different, these plugs, how these work, and this is actually where I had my issue, and I'll talk about that in a moment. But these plugs they work for the EDS solenoid, so the ones that look like this, the black ones, which are a pulse width modulated solenoid valve. And what they do is they sit in here, and when they activate the solenoid, it actually uses this as a little bit of an accumulator. So these things actually get a whole bunch of pressure pushed inside of them, and they sort of blow up like a little bit of a balloon to deaden the effect of the solenoid opening when the clutches are activated. What can happen is that these things can burst. Okay, and this was actually my problem. It was a brand new bit straight out of the rebuild kit from ZF, and unbeknown to me, I didn't even know this problem existed. And the problem I had was that I had my G clutch slipping. So what happens is, I was getting slipping, so the car was revving fairly aggressively and not moving very much in both reversed, first and second, and the only clutch that's common to all three is the G clutch. What I did is I initially, when I first rebuilt the valve body, I actually put this valve body in it. I had the problem, so I thought, oh, maybe something to do with that valve body. So I then rebuilt completely the valve body from my car, and I swapped over these brand new plugs, put them back in again, and as it turned out, I put the same plug, just by coincidence, back in exactly the same spot, because there are three of them, and ended up with exactly the same problems. So, and then just pulled my hair out trying to work out where the actual problem was. I'll talk about where I got the information from in a moment. But enough said that these things, what they do is they blow up, act as a little bit of an accumulator, and because this has actually been a known problem for a while, what they've done since is they've changed the design of these. They're not a rubber little plug, they're actually a little aluminium cylinder with a little rubber bit in the middle, which sits inside there. There's not a hole on the other side of the channel plate, which you would see in one of these. So they can't break, and so you don't end up with this problem. However, the problem is you can't just shove one of the new versions in here. It's actually got to be a different channel plate because the sizes are different. So if you wanted to update yours to the new one, which you can do, you actually need apparently a new channel plate, you need a new spacer plate that goes over the top, and the new plugs, which is, maybe $200 or $300 worth of parts, plus all the oil and gaskets and all that sort of stuff to go with it. So with those parts, there are three of these, and I'll just talk about these now because this was something that was a bit new to me. The way the valve body works is that there are obviously three of the EDS black valves along the back of the valve body. One of them controls a torque converter, and it has one of these. One of them controls only the G clutch, which is this one here, and that's EDS3, and EDS2 controls only the C clutch. All the other clutches are actually controlled by MV1 and MV2, and combinations of those with a bunch of other valves inside the transmission to activate the clutches. But interestingly, EDS2 and 3 activate one clutch each only, the C and the G clutch. I'm not sure if people on E46 Fanatics saw the clutch plates that came out of the transmission that I pulled apart. They were quite burnt, and I would expect that the actual reason for that is one of these, the one for EDS2, which I can't remember if it's this one or this one, I think it might be this one here. It had probably burst, so you're getting less pressure to actually activate the valve to then put line pressure to the clutch itself, and which doesn't obviously allow as much pressure, and the thing slips, and the obviously the transmission doesn't work very well, which was exactly what I was happening with mine. In fact, in this case, obviously it was the G clutch, and the information, like I spoke to ZF here in Australia, I spoke to numerous transmission shops. They had no idea what was going on. After I tested so many things, which I'd explained to them, and then I finally shot off an email to Ericsson Industries over in the States, who were fantastic with how quickly and forthcoming they were with information. They said, yep, this is definitely or most likely going to be a problem, and they shot me some documentation which explained everything to me, and funnily enough, when I pulled it apart, that was actually it. After emptying my transmission probably 5 or 6 times of oil, it was just one little plug that cost about $6 or $7. Right, so if you actually have a problem where the G clutch or the C clutch is slipping, or your torque converter isn't actually activating properly, this is possibly one of the issues that could be. So for example, a torque converter, oftentimes people say it's just the torque converter's toast. It could actually be one of these that's burst, which then doesn't allow the activation of the valves correctly for the torque converter. Right, other things I want to talk about, or some of the things that I actually did to test to see what was going on after I rebuilt it the second time. To actually test the solenoids, because the first thing I did was think, after looking at all the documentation, that EDS3, which controls the G clutch, was going to be the problem. How did I test those? Well, the first thing you can do, these are 12 volt, obviously, because that's what comes from your car. You can just put some jumper leads on these, connect it to a normal 12 volt battery, and it'll just go click and activate. You can do those for they're all 12 volt, even though these are a pulse width modulated valve. They still take 12 volts, and they will just activate on or off with a straight DC 12 volt current. To actually see if it actually works correctly though, you actually need to test it with pressure, and which is again what I did. And this is the thing that I made up. This is just just a normal air pressure gun, which comes from my compressor. I made up a little pipe here and put a couple of hose clamps around the end to hold it really tight. Inserted that at the other end, adjusted my pressure to about 60 psi, because that's what the pressure these things actually operate at. This runs to about 4 bar, it's written on the side of the solenoid, which is around 55, 56 psi. The MV solenoids, they operate to a little bit more than that, to about 70 psi. But all you really want to do is put that in there, and some of these will be either on or off, so they'll either flow or not, depending on what type they are with current attached. It's pretty obvious when you do them. These actually will allow flow normally, and they block it when you attach the 12 volt. So you can attach this, apply some compressed air, activate it with power, and see if it actually stops on it. It should stop the air pressure completely going through it when it's supposed to stop it. Other things, for example, the EDS1 works in exactly the same way, except it's the opposite. So it is going to be closed all of the time until it's activated, and then it'll be open. So I tested that, and they all seem to work perfectly. I tested all the other solenoids from the other transmission, and everything worked perfectly. And still things didn't work. Then what I did was I tested the signal from the computer. So using BMW's INPA, I hooked up the computer, then with the valve body, or the valve body was still sitting there, but disconnected the plugs to each of them and put a jumper lead from the actual harness to the solenoid that I was testing, which was outside the valve body, connected this, and then said activate it using INPA to see if it worked. And again, everything worked okay. I put voltmeter on, the signal coming from the computer to see what was actually supposed to be coming out. Everything seemed to be fine for the MV solenoids because it's just a straight DC voltage. They come out as straight 12 volts straight out of your battery, whereas for the EDS solenoids 1, 2, 3 and 4, they're pulse width modulated. They're 12 volt, but it seems to be about 40% or so. So you get about a 5 volt reading. And with that 5 volt reading that's coming out of it, it again should close it off with about 60 psi quite happily. So after all that, I was still at my wit's end. And then finally, after getting the information from Ericsson Industries, I finally worked out that obviously my plug was the problem, changed that over and it fixed it straight away. To actually test these, so if I were to ever replace, and this is something that Ericsson Industries told me about, was so before they put any of these ever in a transmission, they test these with compressed air. Now they said they tested with about 120 psi. The actual line pressure for the valve body that actually comes in to here, and that's what actually goes to the clutches to activate them, is about 200 odd psi, which is obviously a lot of pressure. These solenoids are rated to a lot less than that, so there's actually pressure reduction valves inside the transmission that allow these to operate at a lower pressure, which is up to about 60 or 70 psi depending on which one it is, which then sends to valves to make them activate. So if these can hold to about 120 psi, then you're good to go, which is kind of the normal pressure that most compressors run up to as a maximum. All I did, you put that on here, hold it like crazy, doesn't get shot to the other side of the room, activate that, and then nothing should leak. What I found with this one, and you're not going to be able to see that on camera, but there's a split in there. Obviously first time, or one of the few first times it was activated, pressure went in there and then it just blew it out the other end. It looks exactly the same, except when you put compressed air on it, just shoots out the other side. So that is definitely something that I would be doing prior to putting any of these in brand new. When I actually realised this one was broken, I actually put the other two, I tested the other two, but I still put the old two back in there because I wasn't prepared. They're probably from the same batch, they could be duds, so I put the old ones back in there, and to be honest, the thing drives like it's brand new. So something to watch out for. Other things that are interesting about the transmission, the screen that sits in here. I thought this initially was going to filter all of the oil that actually went through the valve body. It doesn't. What it does is there are two, initially the pressure which goes down to here, line pressure from the pump or through the main pressure valve, which is going to be at around 200 psi, comes through here and then goes to two pressure reducing valves. The pressure reducing valves are used to then send a datum pressure to both the MV solenoids and EDS 2, 3 and 4, and that pressure that's set to EDS 2, 3 and 4 is modulated by the EDS1 solenoid. So this is obviously considered very, very critical that no gunk actually gets inside here. So when you're cleaning that out, it's obvious, and there's one in the upper rear valve body and one in the lower rear valve body that's above and below this position. Also, what I would think is that from the look of the design, there's very little oil flow in here. So it's going to control the pressure, but you're not going to have lots of oil flow through it. So if things are starting to get a bit clunky on the transmission, this is probably the first place I'd go to make sure everything here is nice and clean and there's no old oil, it's all gunged up. So you get nice, good datum pressure going to the remainder of the transmission to keep everything nice and smooth. That's about it. Hope that helps some people. And yeah, good luck with your transmissions. Cheers.